responsibilities of the highway community. As a leader in that community, you stay informed of the latest research and the changing needs for highway safety. But can you guarantee that the people most responsible for the building and maintenance of our roadways are also informed? The Federal Highway Administration and other highway agencies continually conduct research for safer highways. The research findings are used to design, construct, and maintain highway safety features such as crash cushions, breakaway devices, and barriers. Over the years, FHWA realized that while the research resulted in effective new designs, the effectiveness of these designs was often lost in the field. So we had safety features that worked beautifully in tests or in the plans, but not on our roadways. The problem was found in the methods of installing and maintaining the safety features. People who had never talked to the designer or who had never seen the design in action were entrusted with the care of the safety features. Well, they might have no idea how the design was intended to work or why it worked in a specific way. So the effectiveness of the safety feature might be lost, and the findings of the research not well used. To help solve this problem, this video-assisted functional requirements of highway safety features training course was developed. The goal of the course is to show those who actually select, install, maintain, and repair safety features why they work the way they do, and how the features should be dealt with. Highway people are used to making field modifications in order to accomplish their jobs efficiently and cost-effectively. And some field modifications work well and don't affect the intended performance of a device. However, other modifications have harmful effects and can make the installation totally useless. When we understand how design, construction, installation, and maintenance work together and interact with field conditions, then we understand how the safety feature should work. The Functional Requirements course will assist staff in reaching that understanding by training them first to install and maintain safety features properly so they'll perform as they were designed. Then, second, to recognize hazardous situations and to recommend proper remedial action. And finally, to identify conditions in the field that could make a properly designed feature hazardous, and to take the action that will correct the problem. To show you what to expect, we're going to see some brief excerpts from the video portion of the course. Together, we'll be learning why the installation and maintenance of safety features must adhere to and even enhance the design. Sometimes when you're in the field and a barrier or other safety feature needs repair work, it seems only common sense to complete the work in the fastest and most economical way possible. Now, while this thinking probably applies to many situations in life, it isn't the best way to do the job in highway work. The clear zone is the area bordering the road, starting at the edge of the traveled way, which is available for use by errant vehicles. Now, 4 factors contribute to determining the necessary width of the clear zone. 1, operating speed. 2, side slope steepness. 3, horizontal curvature. And 4, traffic volume. To understand the best contour for the clear zone, we'll look at this film on side slope and ditch tests.
This series of tests was conducted to determine how steep a slope a car could go down safely without rolling over.
The clear zone concept is essential, and we'll discuss it again in connection with other safety features. For now, though, this is the end of our session together. I'll be back to continue our discussion of safe highways. One of the most essential highway safety features is the barrier. Barriers prevent vehicles from crashing into oncoming traffic, from running off bridges, from traveling over cliffs, and from winding up in someone's backyard. The correct installation and maintenance of barriers make invaluable contributions to the total safety system. The Oklahoma Department of Transportation has produced several tapes which can tell us about barriers. Let's take a look at the first one, and I'll be back again at its close.
Traffic barriers are key elements in our effort to design and build the safest highways possible. As the technology of highway safety...
Together, we've seen the four types of barriers: the W-beam wood and steel strong post systems, the box beam system, the concrete barrier, and the cable barrier. Our study of barriers, however, isn't quite complete. To fully understand the safety features of barriers, we need to look carefully at all three sections that comprise a barrier. This session, we've covered only standard sections. In another session, we'll study the end treatments and transitions of barriers. In all our future sessions, we'll continue to explore highway safety features and your role in guaranteeing their effectiveness. Because the end treatments are so essential, special attention must be given to their proper installation, maintenance, and repair in traffic barrier systems throughout the United States. To help us understand end treatments better, the videotape opens with a look at how the type of barrier system is chosen for a particular location, and then looks at each of the four end treatments.
Traffic barrier safety systems, whether they be roadside barriers, median barriers, or bridge rails, all need an end treatment. It makes no difference.
As you've seen, the proper functioning of end treatments contributes to the functioning of the entire barrier system. Another component of the barrier system that we haven't covered yet is the transition of roadside and median barriers to a bridge rail. So we'll understand the role of transitions, we'll look closely at connections with bridge rails, stiffened transition sections, and other transitions. And our exploration of transitions will help you be able to know why transitions are necessary, learn how transitions function, and point out the key elements of good transitions. To see how well transitions work and the reasons why they fail, we'll watch this film on bridge railing and transition crash tests.
This is a standard concrete beam and post railing. Note the open joint. It allows the vehicle to snag on an undeflected post and beam end. This is a test of a typical transition from a guardrail to a bridge parapet. There is no offset between the concrete wall and the W-beam rail. The results of this test are disastrous. This is a retrofit of the previous design. 2 more posts have been added, so the first 4 posts are closer together. A W-beam rub rail has also been added. The test vehicle is successfully redirected.
Throughout this session, we've talked about the importance of correct installation and maintenance of end treatments and transitions. As you've seen, the smooth functioning of these safety features as designed depends on understanding what the design is intended to do. As you saw in several of the last pictures, common sense field fixes are not usually a solution to installation and maintenance problems. Each safety feature has its own unique requirements, and in the next session, we'll learn the functional requirements of other safety features. In this session, we'll investigate highway pavement and shoulders. We'll begin our study with pavement surfaces. Through this study, you'll learn 1. The purpose and functional requirements of highway pavement surface and shoulders. 2. The elements of pavements and shoulders, as well as the characteristics that contribute to poor performance. And 3. the proper and improper installation and maintenance procedures. You've seen that the condition of roadway surfaces greatly affects driving safety. The edge of the roadway, the shoulders, are also an important part of the roadway safety system. We'll study shoulders to 1. Define their purpose and function, 2. Identify the characteristics of shoulders that contribute to proper and improper performance, and 3. Identify proper and improper installation and maintenance procedures that affect safety. Maintenance field personnel can give the most valuable information of areas that will need future improvements. Their comments and suggestions should be sought and communicated to the proper administrative source. Develop that communication channel so improvements can be programmed into future maintenance or reconstruction projects. We'll now watch a film on wet weather accidents. Parts of the film will illustrate our discussion here today. After the film, you'll have the chance to give your comments and viewpoints about today's lesson. In this session, we'll be looking at drainage structures in order to understand what they're meant to do and how they function best. We'll concentrate on describing the purpose of drainage structures, the functional requirements of drainage structures, the hazardous situations caused by drainage structures, and proper construction and maintenance procedures. After everything has been done to improve the safety of one device, lack of coordination between those responsible for different hardware can practically negate everything. In this photo, you see a fixed base support right in front of a sloped longitudinal culvert opening. We've discussed most of these points. As you've seen, any one of them can adversely affect the performance of grates on inlets and culverts, and they can be identified during routine maintenance operations. Some can be corrected easily with maintenance equipment and forces. Those that require design changes or substantial reconstruction can be identified and programmed for future safety improvement projects. We've concluded the video portion of this session, and now you'll have the chance to discuss drainage structures with your instructor. We're now going to take a close look at breakaway devices. During our study, we'll be emphasizing safety performance so that at the end of this session, you should be able to install and maintain breakaway devices in a manner that will ensure they perform as they were designed to. Identify hazardous installations and the correct way to remove or upgrade them. Identify field conditions that may make an otherwise properly designed system hazardous. And recognize whether the installation and maintenance procedures are correct. We have 4 goals to accomplish during this session. First, we need to know the purpose of breakaway devices and how they work. Then, we need to be able to identify safe support systems. Third, we will identify proper construction and maintenance techniques. And finally, we'll describe corrective measures for identified installation problems. We're now going to see 2 videos, one on small sign supports and another on large sign supports. The videos will give you information on installing, maintaining, and repairing most of the types of signs in use today.
Small highway signs are the most common information devices on our roads and highways. They've proven their effectiveness in the past and will continue to save lives in the future.
We're going to leave sign supports now and begin our discussion of a closely related subject, Luminaire Supports. We'll cover the purpose and function of Luminaire Supports, the Luminaire Support Systems, the elements of the Luminaire Support Systems which can contribute to improper performance, and the proper installation and maintenance procedures. The primary purpose of roadway lighting is to enhance safety by extending the driver's view of the roadway. The supports for the lighting fixtures are often a hazard, and so a safety trade-off exists. Both lighting and safety requirements need to be met. Let's end our session by looking at what problems mailbox supports can cause. After this film, you'll have time to talk with your instructor about this session.
When hit, the beam can spear through the windshield, causing serious injuries. As you can see, the consequences of mailbox accidents are not insignificant. The U.S. Postal Service has design specifications for the mailbox itself, but not for the box support. Many of the designs now in existence may be hazardous to the driving public.
Crash cushions shield hazards that can't be moved, so that when vehicles approach these hazards, the crash cushions slow, stop, or redirect vehicles. And in these ways, crash cushions save lives and reduce injuries. For the crash cushions to work, they must be installed and maintained according to their intended design. Different types of crash cushions are important to our study, and each of them is erected and maintained differently. The videos you're about to see will explain these different crash cushions and what you must do to ensure their effectiveness. First, we'll look at sand-filled barrels, probably the most familiar to motorists. The sand-filled barrel is actually a series of crash cushions that rely on inertia. This video will show you how complex the simple barrel really is.
This program will discuss the installation, maintenance, and repair procedures that you should be following when working with the sand-filled plastic barrel crash cushion systems. One of the most effective crash cushions in use throughout the United States today is the guardrail energy-absorbing terminal system, commonly referred to as the GREAT system. And for motorists who needed this safety feature, it probably did appear to be great.
If you follow the sound installation and maintenance practices you've seen demonstrated in these videos, you will have a permanent role in highway safety. In the future, we'll continue our study of other highway safety features and how you can help guarantee their effectiveness. Roadside safety would be great with wide, flat areas along the sides of the roadway. Then, ditches could be located far from the edge of the pavement, and vehicles would have a large recovery distance. In this session, we'll look carefully at roadside slopes and ditches so that you'll be able to, 1, identify the areas of roadside slopes and ditch shapes that affect vehicle safety. 2, suggest alternative safety treatments for slopes and ditches. 3, describe proper and improper installation and maintenance procedures. The FHWA learned through roadside tests that vehicles probably will not roll over on slopes flatter than 3:1 at 60 miles per hour unless the slope is badly rutted. However, neither can vehicles return to the roadway on a 3:1 slope at 60 miles per hour. Instead, they will slide out of control in a circular motion. On slopes steeper than 4:1, vehicles will travel to the bottom before steering control can be recovered. You are the most important part of our highway system. As you've just seen, your performance can prevent accidents, save lives, and affect the safety of millions of people. Traffic control devices play an essential role in highway safety. We'll look at the basic principles of these devices in order to gain a fuller understanding. Our study includes only basic installation and maintenance procedures, not engineering requirements. We'll also study current marking and delineation devices by looking at the purpose of these devices and what affects their performance in the field. Traffic control devices must adhere to set standards so that they achieve a national uniformity. Through a national uniformity, drivers will be able to respond the same way wherever they see the devices. To achieve this uniformity, certain rules and requirements have been established at both the national and state levels. At the national level, the Manual on Uniform Traffic Control Devices is the established standard for all traffic control devices on all street and highways open to public travel. This manual is usually referred to as the MUTCD. I'll refer to it both by the full title and the initials throughout this session. The Texas Department of Highways and Public Transportation has produced a videotape that will show us how markings, signs, and signals form a communication system to drivers. We'll close this session with that tape. You and your agency can make use of this course very easily. The materials are available from FHWA and include a series of videotapes, much like this one, an instructor's guide. All the materials are coordinated to allow a practical and smooth presentation. Participant groups will watch as I explain concepts, show photographs that illustrate my points, and show videos within the video to demonstrate the concepts in action. They will be involved in their learning, much as you are involved now. Of course, the videos are not meant to be viewed by themselves. An instructor should teach portions of the course in which he or she is knowledgeable. The presence and interaction of the instructor greatly influences learning. This video-assisted format gives the instructor an easily managed method of training, standard presentations, time to interact personally with participants, and upgrading of the course as needed. Safety training is often assigned a low priority when in fact it should have the highest. In highway safety training, the welfare of millions and millions of travelers all over the United States every day is influenced by the level of knowledge of highway personnel. With the high turnover in personnel, most new people aren't aware of safety functional requirements. Training in this area should be ongoing to ensure that everyone is familiar with safety requirements. Training is also cost-effective. Even though time is taken away from the actual job, employees are more efficient when they are knowledgeable, and their knowledge keeps the roadways safer, lowering litigation and litigation costs. This course is available, easy to run, practical, up-to-date, and cost-effective. State and local agency, as well as university teachers, are quite capable of serving as instructors. The FHWA sincerely urges your agency to take advantage of this course and that you stimulate interest in this course among your staff.